Okay, in this problem, we're asked to determine the output V0 of t if the signal Vi of t is equal to e to the minus t u of t volts, and the network impulse response h of t is equal to e to the minus 2t u of t, and all initial conditions are 0. So if we go and convert over to the frequency domain, okay, this becomes h of omega. This is V0 over omega. This is Vi of omega. So in this case, V0 over omega is equal to h of omega times Vi of omega. So here's our process in. We're going to go through and convert Vi and h over to their frequency domain components. So Vi of t is e to the minus t u of t. So then Vi of omega is 1 over 1 plus j omega. H of t is e to the minus 2t u of t. So then h of omega is 1 over 2 plus j omega. So then V0 of omega is 1 over 2 plus j omega times 1 over 1 plus j omega. Okay, which is 1 over 2 plus j omega. Okay, we've got 1 over 2 plus j omega times 1 plus j omega. So now we need to do a partial fraction expansion. So we have k1 over 2 plus j omega plus k2 over 1 plus j omega. So now what we'll do for k1, we'll multiply through by 2 plus j omega and let j omega equal minus 2. So k1 then is 1 over 1 plus j omega. Evaluate at j omega equal minus 2. So it's 1 over 1 minus 2, or minus 1. In k2 we multiply through by 1 plus j omega, so we have 1 over 2 plus j omega. Evaluate at j omega equal minus 1, so we have 1 over 2 minus 1, which is 1. So V0 of omega is 1 over 1 plus j omega plus minus 1 over 2 plus j omega. So then V0 of t is e to the minus t minus e to the minus 2t u of t volts.